this computer. Okay. So I want to ask you guys first, can you tell me what is a property of mathematics? Have you ever heard the word property in the context of math? So the word property, now property usually means like real estate, like your parents own a house or an apartment. That's called property. That's called real property. If I own a calculator, that's called private property. Okay, you have private property, you have real property. But in mathematics, and you can all put your hands down now. Let me just make sure that I've got everybody's, let's see, there it is. Participants should be up. Excellent. And also, let's make sure the chat is working. And there we go, and chat. So let's see. Oh, Alexander said he can hear me. So Alexander, we cannot hear you. So can you unmute yourself and speak so I know you can hear me?
Hello.
Hey, great. Alexander, can you raise your hand electronically? That's what we were trying to figure out. And you did. Okay, we're good to go. So everybody's ready here. And the question is, what is a property of math? You can give me an example or explain it. And I want you to raise your hand electronically if you have any ideas. Blake, I'm going to call on you. Go for it. You'll have to unmute yourself.
Property of math?
Yes.
Oh, whoops, I forgot to.
Oh, okay. Okay, okay.
I
want
to raise my hand.
everybody to be unmuted, and I want you guys to tell me about a property in math. Let's try something now. Ready? X equals an integer. Can anybody tell me what is it? Who can tell me what an integer is? And I'm looking for raised hands. The word is integer. Lila, go for it.
An integer is like when you're solving an equation, you put an integer in your equation if you have an unknown in your equation.
That could be true, but you can solve an equation with non-integers, like fractions, like 1/2, or -4/5. Those are not integers. So that's a great start. Can anybody give me a different definition? And Sarah, go for it.
Is it a whole number?
Yes. Oh my God. Integers are the whole numbers and more. They're the whole numbers and their whats. Claire, you know? And you're muted. Everybody should unmute themselves right now. Just, it's easier for me. Guys, look at what I wrote down here. So Sarah was right. It's all the whole numbers, but it's also a whole other set of numbers. And Lila, do you have your hand up for that?
Oh, no.
Okay. So,
Oops.
so Sarah was right. Integers are all the whole numbers and their opposites. So for instance, 2 is a whole number, but so is -2. 7 is a whole number, but so is -7. 0 has no opposite. Now, let's say we say x is an integer, and then I give you a property of mathematics. Are you guys ready for this? This is going to be a property of mathematics. And here we go. A second. Just want to expand the screen here. The property is 2x plus 1 will always be what kind of number? So remember, x has to be an integer. If you take the integer and you put it into x, what does this number always have to be? Anybody have any ideas? And I want you to raise your hand electronically if you do have any ideas about that. And okay, so can anybody try this? Give me an integer that we can try this with. Lila? You'll have to unmute yourself, Lila.
I didn't raise my hand.
Oh, okay, it raised by accident. That's okay. So now let's try this. Everybody take the number 2 and substitute it for x. Go ahead. Substitute the number 2 for x. So we have 2 times 2 plus 1. What kind of number is that? In fact, what is the answer? You can just say it out loud. Guys, what is 2 times 2 plus 1? I know that
5.
everybody knows that.
5.
It is 5. Now pick another one. What about 2, and we'll put in a 1. And what's that?
3.
3. And what about 2 with a 0 in there?
Yeah.
What's that going to be?
1.
And
Zero.
what about a 2 with 3 in there?
7.
Can anybody now tell me what this property is all about? Can anybody tell me what this property is all about? Come on, guys. What do all these numbers have in common?
They're odd.
Yeah.
Yes, this is the property of odd numbers. It will generate every odd number that there is. So properties are used with variables like x to explain mathematics. So let me give you one of my favorite properties of 0. One of my favorite properties of 0 is this one right here. Smiley face plus 0, or A plus 0, or 5 plus 0. Who can tell me the answer to the first one? Come on, get those hands up. Get those hands up. I know you can do it. Okay, so Blake, raise it electronically. Ava, raise it electronically. Caroline, go.
0.
I do not agree. I
Sure.
do not agree, but great first start. I'm going to go with Ava now.
Smiley face.
Yes, Blake, can you give me the next one? Go.
A.
Oh yeah, because of
And can everybody give me the last one?
5.
5.
And so therefore, guys, the property itself is called A plus 0 equals A. Because whenever you have a number and you add it to 0, it will always be that number. By the way, isn't this property exactly the same?
Yeah, it's A.
So whenever you subtract 0, it's also going to be the identity. Now this one, you might say, Kramer, that's not so interesting, but it gets better. What about this property of 0? What about A times 0? Raise your hand electronically if you know that one. Any number times 0. So I have Claire, S, go.
0.
Exactly right. Really, really nice. Now that's a really cool property. Now what about this one? What about 0 divided by A? Caroline, do you have that one?
0.
Yes. I take 0 calculators and I divide them into half. I take 0 calculators and I cut it in half. I got 0. So you're absolutely right. Now, what about A divided by 0? Don't answer out loud. I want you guys raising your hand electronically on this one. And I put everybody's hand down and I want to hear about this. Alana, what do you think about this?
6 o'clock.
Thank you.
A.
Well, think about it this way. I have 10 oranges. I divide it into 0 groups. How many oranges are in each group? I have 10 oranges and I divide them into 0 groups.
0.
It feels like 0, doesn't it? It really, really does.
10.
Wouldn't it be 10?
No, no. In fact, though, Alexander, I do have to say that 10 divided by 1 is 10. Now, that's a whole different property. That's the property of A divided by 1.
So it's 0?
1.
It is not, or A times 1 is also A. So, Alexander, the property of identity for division and multiplication for 1 is A divided by 1 or A times 1. But this one is very strange. Lila, do you have an answer? Do you have an idea? You'll have to unmute yourself because you're muted.
No, I don't have. My hand was up from before.
Okay, no problem. Try to remember if you can. And Caroline, go for it.
Is it 1?
No, that's a good guess, but sorry about this, guys. New property.
Error.
Uh,
It's error.
A divided by A, that's 1. So 3 divided by 3, 3/3 is 1. Now, somebody just said something without raising their hand, but I want to hear from them. Who is that person? Who shared and somebody said error? Who
Sounds-
was that? Help me out.
Caroline, I think.
Was it? Okay. Guys, somebody said error. Somebody said error. Talk to me, please. A divided by 0, all right? Everybody take their calculator. Maybe it's on your cell phone. Maybe it's on your computer. Maybe you have a calculator right there. Take your calculator and literally put into it right now, okay, any number. I literally just put in a random number, and I am going to divide it by 0. And I want to hear what your calculator has to say.
Error.
So yours
Error.
and mine, Blake, says error.
Undefined.
Who says undefined?
Mine.
Undefined.
Alexander's.
Cool.
Mine says undefined.
Undefined is actually a better answer than error. Can anybody tell me why it's undefined? What number or what idea do we have that is actually undefined, Caroline?
So if it's undefined, it's like it's impossible. If it's as error, I'm like, you might be like wondering, well, like it's like they just like it doesn't like if error
says
like,
error.
undefined gives more. It undefined says like it says that like it's impossible. It does not work. While error just says error.
Let me ask you a question. If I wanted to count the integers from 0, 1, 2, 3, 4, and I wanted to go until what number would that be impossible?
Infinity.
And that, everyone, why you can't divide by 0. Because when you divide anything by something infinitely small, like 0, you get something infinitely large. And since infinity is undefined as a number, we say that A divided by 0 is undefined. And can you all write the symbol, please? You can write the symbol this way. You can write it as undefined with a 0 with a /, and then you can even write the word or equals infinity. And just remember, now I am in the process of inventing a calculator that when you try to divide by 0, smoke starts to come out of the calculator and it starts to fizzle, or it starts to play like a big siren, like an alarm, like a fire alarm. Nobody yet has said they will buy my calculator because it's probably going to be unsafe, which is why I'm actually not going to do that. But I would like a calculator that would blow up or start to fizzle if I tried to divide by 0. My calculator, this graphing calculator, it says literally can't divide by 0. So my favorite answer was so far Alexander's calculator. Alexander, do you have anything to add to that?
So what happened if it was exploding or if it like fizzled in someone's hands? If it exploded, then it would cause damage to the human and they would probably either lose a hand, an arm, or a few fingers.
Yeah, and Alexander, that's why I use it as a metaphor. Obviously, this is all a joke. There is no way that I would ever do anything like that. But what I was showing you is that we can't divide by 0. Okay?
Yeah.
You cannot divide by 0, and you should know that that's really, really important. Now, all those properties being said, we are going to play a game, which is literally one of my favorite games of all time. And it is called, well, let me see if you know the name of the game. And what I'm going to do is I'm going to go to random.org. So what I did, well, let's start with this. So I gave you in your packet a deck of cards, but there's something conspicuously missing from this deck of cards. Who knows what's missing from this deck of cards? Raise your hand electronically, please. Come on, I know some people can know this. Are you looking at it? Good, good. I've got some people answering. I got Alana, go for it.
There are no jacks, queens, or kings.
You are correct. Caroline, how many jacks, queens, and kings are there?
Well, there's there's one jack. No, there's 4 jacks, 4 queens, and 4 kings.
Which gives somebody else. What's the total number of face cards? Jacks, queens,
12.
and kings. Everyone go.
12.
Oh.
12. If I take 52 cards and I subtract 12, how many cards are left, everyone? Go. Say it again, please.
48.
40 cards. So 52 take away 12 is 40. Now, there are no jokers in this game. Aces are worth 1 point. And if you don't have a deck of cards, that's why I literally gave you a deck of cards and you could cut it out and make them look pretty. Now, you take a deck of cards and you shuffle your deck of cards. Now, Alana, do you have a deck of cards there?
Yeah.
Oh, that's so cool. So if you took out the face cards, you deal yourself 6 cards. Now, I'm dealing right now these 6 cards. The 6th card that I deal.
I'm gonna get a deck of cards.
Okay, go for it.
Same.
This is called your target number. Your target number is 8. Now, I've seen this game before in school, but the teachers always say, well, you can use a minimum of 2 cards or a minimum of 3 cards. In my game, you must use all 5 cards. All 5 of these cards using addition, subtraction, multiplication, and division, and all the properties I just gave you. And I want you to begin solving for 8. So for instance, I could do, 10 plus 1 is 11. And then I could do I don't know, how about 11 minus 4 is 7, and then I could do 7 minus 7, which is 0, and then 0 plus 8, and I get my target number. So that's just one solution of about, maybe 50 that we could come up with. So everybody get to work. Pick up that pencil. I do not want to see you doing this in your head. If I don't see you writing and really going at it, I know you're doing it in your head. Some people can, but then when I call on them, they can't remember what they did. Please write it down. So Pete, can you get working? So I don't know if you are writing right now, but I want to see that pencil going.
Okay.
Minus.
I see Blake working it.
Mhm.
Claire, Alexander,
Minus
Sarah's working it.
Right.
Ava.
10 minus 1
Mhm.
equals 9.
Oh,
I'm just move 9 on the next move.
Yeah, good.
So then can I it's gonna take 7, 8.
oh, yes. So, Lila, Lila can't get into the meeting, guys. So you guys keep working. I'm gonna try to get her into the meeting.
And you use the -1, the ace. Yeah.
So then maybe
Here it is.
4.
then we could maybe plus an 8. I don't know.
Mm.
9 plus 8. I have a question.
Sorry, go for it.
Do you have to use all the cards?
You must use all 5 cards. That's the difference
Okay.
between the way I play this game and the way others play it.
Okay.
Because it's much more challenging when you're required to use all. And I am sending Lila another invitation here to try to get her back. I'm having a little difficulties with that. So Lila Thornton at iCloud.com. Let's try it. There it is.
I figured out one way.
I just sent it, Lila. Yeah, go ahead. Can you please describe your method to me? Go.
Wait. What?
Go for it, Sarah.
Let's go.
Wait, are you talking to me?
Well, I don't know. You raised your hand and I thought you said you had a solution. So I put 2 and 2 together. Go for it.
I did.
Go for it, kid.
I did 10 minus I did 10 minus 1 equals 9.
I like it.
9 plus 7 equals 16. 16 divided by 8 equals 2.
Whoa.
And then
Yes.
2 plus 4 equals 8.
2 what?
I mean
4?
plus. No times.
Yes. Okay. A very, very elegant solution, Sarah. I love it. Now, Sarah, find me another one. And Claire, go for it. Claire S.
Well, I didn't use division or multiplication.
Oh, guess what? You do not need to. You do not need to. Let's hear what you did to solve.
Well, I did. I think. Well, I forgot to do those cards and I used my own cards. And
Oh,
yeah.
okay, so you're doing a different grouping. So can you do me a favor, work on this one so everybody else can see your solution, and then maybe you'll give us your cards, and then we can solve that, okay?
Okay.
All right, excellent. Now, Claire, not S.
I did 10 minus 4 plus 8 plus 1 plus 7
10 minus 4, hold on, is 6. Keep going.
plus 8,
Plus 8 is
14
good.
plus 1, which is 15, and then 15 minus 7.
Oh my God, that is so awesome. That was a great, great method. And Lila, you're back. Yay. Okay, so Lila is back. Pete, you have one for us? Pete, you working this? And Pete, turn on your sound, because even though you're not muted anymore, I can't hear you. So it's not your mute, it's the sound on your computer.
Hear me?
There you go. I got you now, buddy.
I'm still figuring it out.
Okay, cool, cool. Who's got another one? Blake, come on. I know you've got that. Caroline and Alana, I know you've got one. Ava, what have you got for me?
Well, I did the same one as Claire.
Really? That's so cool. That's very cool. So guys, I want to show you just one right here. Alexander, you working on this? Is that a yes? Okay, good. Now, I want you guys to watch what I did. I love multiplication like Sarah used. So I would use 10 times 8 is what, everybody? Go.
80.
80. Now, if I want to take 80 and divide it by some number to get back to 8, what is that some number going to be?
10.
10.
So guess what? Can you make a 10 from 7, 4, and 1?
Yeah.
Do it. Out loud. Go.
7 plus 4 minus 1.
Yeah.
That's it, guys. 11 minus 1 is 10, and 80 divided by 10 is 8. Now, I have to say that I did that solution, and then guess who did that exact same solution during my last call? And it was Caroline's sister, Ellie, who did that one. And I thought that was really, really cool. Now, the other thing is are you guys ready for Claire S? Claire S is going to give us her cards. So Claire, go ahead and give us your cards, please.
I had 1, 6. Well, no, I just had a 6.
Oh, okay. 6, keep going. 6.
2. 2. And 1.
I need 5 cards plus a target. Remember, there's got to be 5 cards plus your target card.
My target card was 8.
Target was 8, and what is the 5th card?
3.
Okay, everybody get to work, guys. Everybody get to work. Your job is to make 8 from 6, 2, 2, 1, and 3. Everybody start to work it right now. Go. Come on, get that pencil moving. Pencils, pencils, pencils. Come on, guys. I want to see those moving. Oh, I see a really cool one. Claire. And Claire, I love those. Claire, can you give me your solution for that, please?
Plus 2.
You have to do a little bit louder for me. Your volume is way, way down.
6 plus 2.
So 6 plus 2, I heard. But you have to say what it equals.
Equals 8.
Good.
8 plus 2 equals 10.
So 8 plus 2, I heard.
Plus minus 3.
Say again, please.
Minus 3.
Minus 3 is
7.
good.
Plus 1.
Amazing. I love it. What an elegant, elegant solution. Caroline and then Alana. Go, Caroline.
I just had one, but I realized it equals 7, not 8.
Try to see if you can fix it to get back to 8. That's a really cool thing. I do that half the time. I'm off by 1. Alana, what do you have?
6 plus 2.
You have to say 6 plus 2 equals,
8.
keep going.
And then 8 minus 2 equals 6. And then 6 plus 3 equals 9. And then 9 minus 1 equals 8.
Amazing. Pete, give me yours, please.
3.
Plus 2 is 10. And then
Say again, please.
plus 2 is 8. And then
Okay, you know what? Do me a
plus
favor.
2 is
You have to- can you speak into the, like, face the computer, because then I can read your lips because I can't actually hear you very well.
I can type it if you
No, just say it, but more emote. Give me a little bit more volume with your voice.
6 plus 2
Got it.
is 8.
Excellent.
Plus 2 plus 1 is 3 minus 3.
Oh, wait. So 2 plus 1 is 3 minus 3. Oh my God. Dude, that's awesome. That's a beautiful one. Ava has one.
I did 2 plus 1 is 3. And then I did 6 plus 2 plus the 3 I just made.
Good. So 8
And there's
plus 3
11.
is 11.
And then there's a 3 card, and I minus 11 minus 3 is 8.
Oh my God. That is magnificent. What a beautiful job. I'm going to choose Sarah, then Claire P. Go for it, Sarah.
So I did 6 times 2 equals 12.
6 times 2 equals 12. I love multiplication.
12 plus 3 equals 15.
Mm.
15 plus 1 equals 16.
Wow.
And 16 divided by 2 equals 8.
Wow. Another beauty. Elegant, elegant, elegant solution. Claire P, go.
I did 3 plus 6 equals 9. And then 9 minus 1 equals 8. And then 8 plus 2 is 10. And then 10 minus 2 equals 8.
Excuse me, everybody. That is also absolutely beautiful. Guys, you know, Claire S., that was a really cool group of cards. Are you guys ready for random.org to happen? Are you ready for random.org? Here we go. by the way, I put random.org in your packet. So you actually have not only the website, but you have it, I actually programmed it for you. And the way I programmed it is that it eliminates all the jacks, queens, and kings. It also eliminates the jokers. It also will give you 6 shuffled cards every time perfectly. So I'm going to hit the word again. And I want you guys to write down these numbers. 5, 2, 10, 9, 2, and 8. I'm going to copy them into our document. 8 is our target number. And I want everybody to come up with multiple solutions. And let the games begin. I really love this game.
Which one is your target? Oh, 8.
Well, you know,
It's always 8.
I just randomly decided that the last card is the target. That's just the way I play. You guys can play it however you want. That's 2. So if I had a 4 times the 2. Pete is our first winner here. Pete, go for it, man.
So I did 10 plus 9 is 19, minus 5, which is 14, plus 2, which is 16, divided by 2, which is 8.
Wow. That's beautiful. Wow. I almost want to say that that was a Sarah-esque solution with that beautiful division. I was actually looking, Pete, for a 16 divided by 2, and I didn't find it. So that was really cool. Find me another solution there. And does Ava, Claire P, and Sarah, are your hands up for now or from before? If they're up.
That was from before.
Before.
Okay, so then put those down just so, this is so cool, Pete. Really excited about this. I'm gonna go try to find something again that works really well. Let's see. Ooh, that 9. 9 is giving me a problem. 9 is giving me a real problem. So I need a 3. 9 divided by. I think we have another. So we're going to do Ava and then Claire P. Go, Ava.
10 times 5 is 50.
Whoa.
And then 50 divided by 2 is 25. 25 minus 9 is 16.
Huh.
And then 16 divided by 2 is 8.
Wow. That is so cool. So you kind of got to 16 with a remainder of the card that's 2, like Pete did, but you got there a completely different way. So awesome. Ava, try to come up with another one. Claire P.
5 plus 2 equals 7. And then 9 plus 2 equals 11. 7 plus 11 equals 18. And 18 minus 10 equals 8.
Wow. That is so, so cool. Claire S., did you have another one?
No, I just realized that it was incorrect.
You know, those incorrect ones sometimes are the best. I'll tell you, they really are. So I'm looking for, let's see. Wow. All right. I'm gonna, while you still work on this, and Claire, do you have it?
Yeah, I got it.
Oh, good.
10 times 2 equals 20. 20 plus 5 equals 25. Minus 9 equals 16
Wow.
divided by 2.
Unreal. Unreal. Such beautiful work. You guys were going to be, I don't even know if I could beat you guys in this game. I mean, this is, you guys are really, really good. It's because this is not easy stuff. Now I want to go to my random.org again. Let's come up with a new one. Oh, guess what? We have one without an 8 as a target number. But of course, there's an 8 in it. And our target number is 7, which, believe it or not, happens to be more difficult than target numbers of 8. And the other question I want you guys to think about
That's
is
odd.
this. The other thing I wanted you to think about was this. The other class challenged me to say, Kramer, are there any groups of 5 cards and a target that can't be solved? Can you come up with anything that can't be solved? And when we did a little bit of probability math in the other class, I want you guys to look at this. I figured out that there were 810,000 combinations of 6 numbers in this method. 810,000 combinations. Now, I've tried maybe 1,000, but clearly not 810,000. So is there one that I can't solve? I would be so excited to see it. So I want you guys to try to help me. Now, Claire, do you already have a solution for this? Go for it.
5 plus 5 equals 10. 10 minus 8 equals 2. 2 plus 4 equals 8. Or no, 6.
Good.
Plus 1 equals 7.
You know, it's simple, it's beautiful, and I love it. Guys, I want to show you a little trick. Everybody stop for a second. Everybody stop for a second and look up at the screen. Now, I've got a very special number here. You ready for this?
Yep.
One of my favorite properties is A minus A. So 5 minus 5 is what?
0.
One of my other favorite properties is 0 times a number. And 0 times 4 is what?
0.
It is 0. Now, why did I care so much about 0? And the reason is because I saw 8 minus 1. And because I saw 8 minus 1 was 7, all I needed to do was take the other cards, get myself to 0, and then add 0 to 7 to get my 7. So that is kind of a fun way to get there. So
That's what I was going to try to do.
oh, cool. Cool. You know what, Lila? I'm going to challenge you I think there may even be another way to do that in this grouping. Alexander, you have anything for me here? Blake? I'd love to hear. Ava's got one. Go for it, Ava.
Um, so 5 times 5 is 25.
Oops, hold on. I lost the cards. Hold on a second. I'm going to try to get them back. I think, there it is. Okay, so start me out again. I apologize for the interruption. Go.
That's fine.
So what's your first?
5 times 5 is 25.
Beautiful.
25 minus 8 is 17. And then I did 4 plus 6 is 10.
Wait. Where's the 6?
I turned the ace into 6.
Ah, the ace can only be equal to 1. The ace can only be equal to 1. So when you think of an ace, just think of the number 1.
Okay.
Ace is not like a wild card, like a joker might be able to be anything you want it to be, but not the ace. That's a great try. Claire P, do you have one?
Yeah. 8 times 4 is 32.
Ooh, another one with multiplication.
And 5 times 5 is 25.
Wow.
32 minus 25 equals 7. And then 7 times 1 equals 7.
Oh my God. Claire, all I have to say is that is awesome. That was so cool. Oh, by the way, guys, could Claire have also done 7 divided by 1? Yep. So that would also yield 7. Now, wow, that blows me away. Now, guys, I have a challenge for you. Ben L, in my last class, he thought he found a combination that would not work. His combination was 1, 1, 1, 1, 2, and 9. So 9 was the target.
I was going to try that one.
Yeah, it's really interesting. I want everybody to try to make it work. I came up with 2 solutions, and one of them,
What's the target?
the target is 9.
Okay.
9's in red, right? Always that last number is going to be our target.
So what's 2, 3, 4, 5, 6? So we have to do some multiplication.
I don't
1, 2.
divide.
Now, one of the solutions is really, really simple, and one of them is really, really hard. But you have to keep writing. You have to write down 1,000 different things. Like I had to, go like this. What happens there? Oh, too bad. That's only a 6. And I'm going to let you struggle with this for a few minutes. So give it a few minutes. Pete, I love your comment, Pete. This is cool. So Lila asked a question, can you combine like the 1 and the 1 to make 11. And no, you cannot. That's a really, really good question, but no, Lila, you cannot. But that, I really like that question. And Caroline, do you have an answer for this one?
I'm trying to think of one, but I can't really think. Kind of hard.
Okay, guys. Would you like to see the 2 solutions I came up with? And that doesn't mean there aren't more.
Yes.
Now, the first one I'm going to give you is, I kept looking at this and I could not figure it out. And then all of a sudden, it came to me. Are you ready?
Yep.
1 plus 1 plus 1 is what?
3.
3.
And 2 plus 1 is what?
Oh my god.
And 3 what?
3 times 3 is 9.
Oh.
And
That's
isn't
so
that like,
simple.
I mean,
Yeah, I think I figured that one out.
now that one kind of felt good, but the other one, guys, this, you may not know how to work with it yet, but I want to show you something really cool. Are you ready? What if we did 1 plus 1 plus 1 to get 3?
Yeah.
You ready? Now, I'm going to take this 2, and I am going to raise it to the 3rd power. Now, when I do that, that's the same as 2
Times 2
times 2
times 2.
3 times. So it's 2 times itself.
It's 8.
3 times, which is 8. And then 8 plus 1 equals 9. And that was the other solution that I came up with. Now, that was a lot of fun for me to find because I hadn't used exponents before, and it was a great challenge. Can anybody try to come up with a combination that does not work? I mean, to me, it would be so cool to find one. In fact, I challenge you mathletes, come up with these great cards and then send me and say, Kramer, I bet you can't come up with a solution. All right? And first, you and your parents try it and really try to do whatever you can to find a way to stump me. Remember, 810,000 combinations. There's got to be one that doesn't work.
1 for 1, 1, 1, 1, 1, 1.
Ah, now you are brilliant because I would love it if I could have more than 4 ones. But remember, it's a deck of cards. So a deck of cards, you're never going to have more than 4 ones. But you know what, Pete? You just gave me an idea. What if we said you're allowed to have 2 decks of cards? Now, doesn't that change things? Yeah. So I kind of think that Pete's idea is a really good one. Claire, do you have an idea? Claire?
No, I was just stretching.
Oh, okay, good. So guys, I hope that you love the game as much as I do. What I gave you is on this page right here, I gave you 6 solutions for the first problem that we did. And then I gave you 4 combinations and another 4, so a total of 8 challenges.
Okay.
And I also gave you 1 solution for each of those. And I want you to push yourself. Push yourself to have a lot of fun with this, okay? Now, we're gonna do our cheer today, but we're gonna use a number that is related to a deck of cards. So every single suit in a deck of cards has 13 cards. So we're going to go from the number -52 by 13. All right, let's do it, guys. Go. Negative 52.
Negative 52.
Negative 30,
37.
Close.
38.
Closer.
9.
39. So remember, because 13 plus 39 is 52. So keep going.
Negative 26.
Beautiful. Keep going.
Negative 13.
But
Negative
don't
13.
ever say negative
Negative
0. 2, 4, 6, 8. Voodoo, medium, 58. Integers. Integers. Go integers.
Integers.
I will see you in an integer number of hours. Well, actually, that is true exactly now. So I'm going to say goodbye to everybody. You were absolutely awesome. I'll see you in 167 hours. Please send me your challenge combinations so I can be stumped. It'll probably keep me up at night, but those are the kinds of things I love. Everybody be well, and thank you so much.
Bye.
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 Ace of Spades skateboard. That's really cool, Pete.